Okay, let's dive right in. Today, we're tackling what feels like factoring's final boss. You know, those classic algebra problems that look like they're going to be a total headache. Well, we're going to make them simple. I'm going to show you a powerful algorithm that turns them into a piece of cake.
But hey, before we take on the final boss, every hero needs a warm-up, right? So let's start with something familiar. A simple puzzle that'll build our confidence and really set the stage for what's coming next.
So when you see a trinomial like this one, where the first term is just a plain old x squared, what are we even trying to do? We're essentially trying to do multiplication in reverse. We want to break this thing up into two smaller pieces, two binomials, that are being multiplied together.
It's basically a little game. You look at that last number, 6, and you think, okay, what two numbers multiply to 6? Then you check if any of those pairs add up to the middle number, 7. And boom, it's got to be 6 and 1. This method is awesome, it's quick, and it works perfectly for these simpler cases.
Okay, but here's where the puzzle changes. A new player enters the game, and suddenly the rules we just used don't quite apply anymore. This is where things can get messy and fast. Just take a look at the difference here. On the left, our simple, friendly puzzle. On the right, the trickier version. As soon as that leading coefficient, that a value, shows up, like the 6 right there, our simple logic kind of falls apart. You could try to guess and check all the possible combinations, but honestly, that can turn into a real nightmare.
So what do? Just guess and hope for the best? No way. There's an elegant, systematic algorithm that takes all of the guesswork out of it. There's a method to the madness, and it's called the AC method.
It's this super reliable process. Sometimes you'll hear it called reverse FOIL. And it's an absolute game changer for those tricky problems where A isn't just a 1. It gives you a clear, systematic path to find the right numbers every single time.
You might be wondering, why the AC method? And that's a great question, because the name literally gives you a massive clue about the very first and most important step of the whole process. And that's it, that's the secret sauce. The entire key to unlocking this puzzle is to start by combining the information from the first and last terms. You literally multiply A times C. Let's see how that one simple move opens up the whole problem. All right, let's put this method into practice. We're going to grab that tricky puzzle from before, 6x squared plus 11x plus 3, and we're going to walk through a clear, 4-step process to solve it.
Here they are, the 4 core steps. Step 1, we multiply A and C. Step 2, we find our two magic numbers. Step 3, we rewrite that middle term. And step 4, we factor by grouping. Simple as that. Let's do it.
Okay, so this little X trick is a really cool way to visualize what we're looking for. At the top, we put our A times C product, which is 18. At the bottom, our B value, which is 11. Now the hunt is on. We need two numbers that multiply to 18, and those same two numbers have to add up to 11. And there they are. It's got to be 9 and 2. 9 times 2 is 18, and 9 plus 2 is 11. Perfect. Okay, now here comes the really clever part of this whole method, what we do with these numbers.
Yeah, just like this quote from Geeks for Geeks explains. We're not solving it just yet, we're just rewriting it. We're going to use our 9 and our 2 to split that middle term, that 11x, into two separate pieces. We're breaking the problem down to make it easier.
And look at that transformation in action. We go from 3 terms to 4. Now you might be asking, why would we want to do that? Well, it's because having 4 terms is the magic number for a really cool technique called factoring by grouping.
So we pair them up. In that first pair, what's the biggest thing we can pull out? A 3x. And in the second pair, well, just a 1. And would you look at that? You see it? That same binomial, 2x plus 3, is now in both parts. That's the signal that it worked. So we pull that whole thing out to the front, and what's left over? The 3x plus 1. And there's our final answer. Solved systematically. Absolutely no guessing required.
Now, the AC method is amazing. It feels like a mathematical superpower. But like any tool, you've got to know when to use it and when not to. What's cool is it not only gives you the answer, it also tells you when an answer can't be found this way.
Right, so what happens if you're staring at that X diagram and you just can't find two integers that multiply to AC and add to B? What does that mean? Well, as Dr. Peterson points out here, it's not you, it's the problem. It's a signal. It means the expression isn't factorable using nice, clean integers, and it's time to reach for a different tool in your toolbox.
I like to think of it like this. The AC method is like your precision screwdriver. It's perfect for a very specific, common job. But the quadratic formula, that's your power drill. It will work on everything. It can solve any quadratic equation you throw at it. The real skill is knowing which tool to grab for the job at hand.
So, let's wrap this all up. What's the big idea to remember from all of this? What's the new superpower you've just unlocked for your algebra toolkit?
What this all comes down to is a shift in strategy. The AC method is a system. It's an algorithm. It transforms what can be a really frustrating guessing game into a reliable, step-by-step process you can trust. It takes the anxiety out of these problems and gives you a clear path to the answer.
And that's a really powerful idea, isn't it? It kind of makes you wonder, what other big, complex problems, maybe not even in math, but in life, could be simplified? Not by just guessing and hoping for the best, but by finding the right, elegant algorithm to solve them. Definitely something to think about.